So, what happens when we have an open dot? Means it's a composition of a function. So which one is embedded in which? G is embedded in F. So we have H equals F of G, technically. This one wonky spot on my board really drives me crazy. Okay. And you have a composition of a function and you need to take the derivative of it. That's, for example, like if I gave you x squared plus 1 to the 2. This would be like the G, right? And then this bracket with the square would be like F. We agree? How do we do this function? You take the 2.
X squared plus 1.
Yeah, you go to x squared. Over the x, sorry. 2x squared plus 1 to the 1, technically. And then you chain what? The derivative of the inside, which is g. Right? So we do 2x. So what do? We take the thing, drop it in front. Okay? All right. So we have h equals f of g. Try it out. What do we have for guesses? What could we do? What did we do over there? We technically did the derivative of the outside function, correct? What is the outside function on this one? F. So h prime, we'll say, of x would be, we did f prime, correct, of x. But what's x in this case? G. So we did f prime of g, right? And then what do we multiply by? G prime. We agree? It just looks really stupid without x's. So this would be f prime of g of x. I want to write the g's. F prime of g of x. And then times g prime of x. Right? You just do the derivative of the outside, keep the inside, and then the derivative of the inside. Because you're working away from out to in, correct? Now this one, when we did the derivative of the outside, it was drop the 2 in front, rewrite it to the 1. That is the derivative of this one. We just don't have an option of like doing the derivative of that. We agree? So we write f prime, that's the derivative of the outside. We keep the inside, multiplied by the derivative of the inside. So we do the derivative of the outside, rewrite the middle, derivative of the inside. That's all I did. So I did the derivative of f, which we did there, rewrote the middle, chain rule, so we chain the derivative of the inside. Okay? But we don't want h prime of x, we want h prime of 1. So we're going to go f prime of g of 1 times g prime of 1. What can we fill in currently? G of 1 and g prime of 1. That's all we can fill in, correct? So we're going to go h prime of 1 equals f prime. What's g of 1? It's 2 times g prime of 1? Negative 3. Now what can I do? Yeah. Find f prime of 2. It's just like composition from 30-1. So we did this first, then we can do that. F prime of 2 is negative 4 times negative 3, and it's 12. So a whole bunch of excess information. So go to 3.1 and try 81. Go do that right now. Section 3.1, try 81. So this one is differentiating exponential functions with a numerical base, which we've done this before. This is just a repeat of everything we've done. So whenever we take the derivative of an exponential function, right, with a numerical base and a variable exponent, what do? We rewrite it, ln the base, and then what? Derivative of the exponent. So there's always 3 chain links, right? So let's go here, differentiating exponential. So determine dy or dx, so determine the derivative with respect to y of the following functions. Y equals 2x, to the x. So we go y prime equals, and what do? Rewrite it. 2 to the x. So that's our first step. Then ln 2, which is not actually a nice number, so it stays as ln 2. We've always had ln e for the most part, right? Which went turned around, sorry, to 1. And then what do we have to multiply by? The derivative of the exponent, which is 1, which I didn't have to write, but I'm proving a point. So when you do these, there should be 3 chains in this little link. So it would just be 2 to the x ln 2. Or sometimes it's ln 2 to the x, whatever, it's the same thing. You don't have to put the brackets, but I'm going to. Okay, you try B and C. So here we have y equals 3 to the negative x. So we're going to go y prime, we're going to rewrite it. On the base, derivative of the exponents. Now often they won't leave the negative one sit at the back, they'll just bring it to the front, right? But if you left it like this and it was a written response, you were not wrong, it just won't match the answer if it's a multiple choice. So often they'll write it as negative 3 to the negative x ln 3. Okay, this one, y prime equals, rewrite it, on the base, derivative of the exponent is not x, 2x. Done. Try those. So, for C and D, I can't remember how much paper is actually on, not a lot. For C and D, I would do them on a separate sheet, personally, but up to you. Because it's going to be a product rule and a quotient rule. Well, D is a chain rule with a quotient rule embedded. Okay, so f of x, the first one is just a plain old chain rule, right? Whenever we have a function embedded in another function. So how would we know? What would the original function be? It would be x to the negative 5. That would be your f, right? And then your g would actually be 3 minus x cubed, and then this would be f composed of g. That's what this is. So whenever it's a function composed in another function, you have to use chain rule. For this one, it would be cos cubed x. That would be your f, and your g would be 4x, and then it's composed again. So whenever it's composition, you have to use chain rule. So here we go, f prime of x equals, what would I do first? Negative 5.
3 minus x 3.
Yeah, rewrite.
Or to the negative 6.
To the negative 6, because we have to drop it by 1.
3x squared.
Minus
Or
3x.
minus.
Yeah. So what they'll do is they'll join the negative 5 and they'll join the negative 3x squared together. And what do you think they'll do with that middle one?
Leave it. Oh.
Drop it to the bottom and make it positive. So they'll go 5 times negative 3 is 15x squared over 3 minus x cubed to the 6. Just remember, if there's a negative exponent, you can just move it to the other one. If it's in the denominator, move it to the numerator. If it's in the numerator, you move it to the denominator. It makes it positive. Grade 10 really comes back to haunt us every so often. It's grade 10 again. I say us because I feel haunted. I don't know when it's going to stop. Grade 10 doesn't haunt me anymore for the grade 11s. It's now grade 9 that haunts me for those. Hopefully the haunting stops after this year. Okay. So we have f prime of x. So this is what I'm not going to do f, well, over here. I'm going to write f of x first. If I ever get it like this, okay, do you see how there's that 3 in there, in the middle? You can't do the derivative with the 3 in the middle, just like you can't type it into your calculator like that. There's no way you can type your calculator like that. The moment you press cos, the bracket opens up. We agree? So where do you put the 3? You can't put it in the bracket. That's not where it is. So how did I tell you you have to do it so you can put it in your calculator? Podmore, I'm going to break that phone.
I was just checking on you.
Oh, good, sure.
Calculator.
Cool. Okay, so we have cos cubed 4x. How do we write it? So that we could, how do we type it? We would have to go full brackets, cos 4x to the 3. That means that there's 3 cos 4x's, correct? When they put the 3 in the middle, that means there's 3 cos 4x's. And the reason why they put the 3 in the middle is if they put the 3 at the back without brackets, it's actually just on the 4x, right? Like if the 3 was here without brackets, that would mean that the 4x would be cubed, not the whole thing, correct? So instead of doing like the brackets, they write it like this. But in order to do the actual derivative of this, we have to write it like this. Cos 4x cubed. If you remember to do that every time, you'll get the question right. If you don't, sometimes you get it right. So I always just do that. So you have to rewrite it the way that you would type it into your calculator. Okay? So how do we do this? We go 3, rewrite the inside, cos 4x, all to the 2. Now we have to times it by the derivative of the inside. What's the derivative of cos 4x?
Negative sine.
Negative sine 4x. What haven't I done yet? The 4x, which is just 4.
Oh my gosh.
So you work your way from outside in. So you drop the 3 down in front, rewrite the inside to the 2. Then you do the derivative of cos 4x, which is negative sine 4x. And then you do the derivative of the 4x, which is 4. So you work your way from outside in. So you go 3, drop in front, cos 4x to the 2. Then the derivative of sine 4x, or cos 4x, sorry, is negative sine 4x. But then we still haven't done the derivative of 4x. So then we put behind it 4. So you work your way from outside in, outside in. Now it's putting it back together, because they're not going to leave it like this. So we have a coefficient of 3. We can multiply that by the negative 1 in front of the sign, right? And by the 4. So what do we get? Negative 12 sine 4x. If you put the sine 4x last, it doesn't matter. And then what they'll do is they'll take this 2 and put it back in. They'll never write it like this with the brackets. They'll write it as cos squared 4x. So whenever you have a cos or a sine or a tan or a secant all to an exponent, that exponent can come and get set into the middle. What's up with C? We have variables in 2 things, and they are multiplied. I always put a little multiplication dot in there, because then it screams product rule. If you don't put the multiplication dot, you won't do product rule. You'll just do the derivative of e to the x, derivative of the other one, and be done. And the answer will be there, and it's super wrong. Okay? So, like I said, you might want to do this on a separate sheet of paper, because it takes a bit of room. So, D takes up more room. So here we're going to have an F, and then here we're going to have G. What's F prime? E to the x. So this question, the actual derivatives of the different things are not the hardest part. And most people will do really well on this if they recognize it's a product rule. It's the recognizing it's a product rule that is where it goes badly, right off the hop. G prime is a chain rule. So this is a chain rule embedded in a product rule question, right? So what's the derivative of x squared plus 1 to the 3?
3x squared plus 1 squared times 2x.
Times 2x, and then they'll bring the 2x and the 3 together, and they'll write it as 6x x squared plus 1 squared. Now, please pay attention. Remember how when we had the e to the x, I told you when we did product rule or we did quotient rule, if we had an e to the x, we'll always be able to take an e to the x out because they're the same derivative of each other. Then your first step is always to rewrite it, right? So you always be able to take that out. This is also something. If either your f or your g is a chain rule, you will also be able to take some of those out. Because this one has an x squared plus 1 to the 2, and this one has a x squared plus 1 to the 3. So I'll be able to take an x squared plus 1 to the 2 out of both of them. So whenever your f or your g is an e to the x of any shape, you can take that out. If your f or your g is a chain rule of any shape, you can take that out. And the reason why you can take the e to the x out is e to the x actually uses chain rule, right? I just showed it to you. And when you have a numerical exponent to a numerical base to a variable exponent, you use chain rule, right? So whenever you use chain rule, you can always take out something. Okay, let's start writing it out. So we have f prime of x equals f, which is e to the x, times g prime, which is 6x, x squared plus 1 to the 2, then plus g, x squared plus 1 cubed, times f prime, which is e to the x. When we do product rule, we end up with two terms, correct? Because terms are connected by plus or minus signs. So the first term is e to the x, 6x, x squared plus 2, x squared plus 1 to the 2. Your other one is x squared plus 1 to the 3, and e to the x. So out of the blue and out of the blue, the two blues, what can I take out for GCF? I can take it, yeah. So I can take an e to the x out and an e to the x out. Put it in brackets. And then I can also take out an x squared plus 1 to the 2. Because this one has 2 of them, this one has 3 of them. I can take out at most 2. You always have to take out the smaller one. Now the great thing about this is if you do a chain rule correctly for a product rule or quotient rule, you will always be left with one of the, so when I take the x squared plus 1 to the 2 out, one of them terms it'll completely go out of, the other one there'll be left one of. Okay? So what does that mean? Well, let's write this out. X squared plus 1 to the 2. And then I'm left with what's left over. So 6x is only left here. This one went away, correct? Plus, and then what am I left with? X squared plus 1 to the 1. If one of them doesn't go away and the other one isn't left with a 1, you did something wrong. So when you take a GCF of them out when there's a chain rule, it actually makes it really super uncomplicated in the brackets. If it's still complicated, you got problems. So x squared plus 1. Now, it bothers me to all heck that these are not in order, but because I'm a rebel, I'm going to box it because it doesn't matter. Because 6x plus x squared plus 1 is the same as x squared plus 6x plus 1, right? As long as you know that. This is a written response, done. You don't have to reorder it. You're not going to be like, didn't go in reducing exponents. Can't deal with these people. So this one was a chain rule embedded in a product rule. We agree? There was a plain old product rule, and we only use chain rule to get the G. We agree? This one is a quotient rule embedded in a chain rule. Because we have to do the outside first, correct? So we're going to need space. Oh, I don't even know what I just did. Whatever. Okay. So the first thing we're going to have to do is just the chain rule. Okay? Everyone paying attention? I don't want to lose you. Always. So f prime of x equals, what are we going to get first?
4x, oh wait, chain. First there's 5.
5.
Rewrite
the inside. 3x plus 2, 4x squared minus 5 to the 4. So that's not crazy, right? We just did the outside first, correct? Now we have to do the derivative of the inside. The inside just happens to be a what? A quotient rule. You see that? So now we're just doing a quotient rule like we did before. This is anything crazier than what we did before. So let's look at it. This would be my f, this would be my g. My f prime would be 3, and my g prime would be 8x. Do you see that? Does that make sense to people? Then we're going to go gf prime minus fg prime all over g squared. We're just doing quotient rule like we did in quotient rule. So I'm going to get a big bracket. I just put it as a square. You can do whatever you want. So I'm going to go g, which is 4x squared minus 5, times f prime, which is 3, minus f, which is 3x plus 2, times g prime, which is 8x, all over g squared. What did we do next in quotient rule? Yeah, we distribute that top and collect like terms, right? We did that in quotient rule the whole time. So I'm going to get 5, rewrite this, 3x plus 2, 4x squared minus 5, all to the 4. And then I'm going to get 12x squared minus 15. And then I'm going to make the minus with this. I'm going to get minus 8x and distribute. So I'm going to get negative 24x minus 16x. Let's try again, 24x squared. Then we collect like terms.
What was it before you said not to expand? It doesn't seem like that. It was at the bottom.
Yeah. Yeah, I was just make the denominator squared.
Okay.
And then we're going to get negative 12x squared minus 16x minus 15. And most people want to stop here, but it's not going to match your answer. And I'll show you, the next step is really, really easy. It's just remembering to do it. Then this last step to put what together isn't the hard part. It's just remembering to do it. So this is not incorrect. It just won't match the answers. And the reason why is this is technically 5 over 1. We agree? But if you look here, I have a 4x squared minus 5 and a 4x squared minus 5 squared. I'll be able to put them together. However, what do I have to do first? This is from grade 10 again. The 4 has to go in. So the 4 goes into the numerator, and the 4 goes into the denominator. And it's really easy, because you literally just write the binomial to the 4, the binomial to the 4. Like you're not expanding it or doing anything crazy. You're literally just writing 5 over 1, 3x plus 2 to the 4, over 4x squared minus 5 to the 4, and then negative 12x squared minus 16x minus 15, 4x squared minus 5 squared. And then they just put all the numerators together, all the denominators together. The numerators can't go together. They literally just get written side by side. They're chains. So I'm going to get 5 times 3x plus 2 to the 4 times negative 12x squared minus 16x minus 15 all over 1, which you don't have to write. And then 4x squared minus 5 to the 4 times 4x squared minus 5 to the 2. When I have 2 bases and 2 exponents, what do I do with the exponents? Add them. So I have 4 of them and 2 of them. Now I have 6 of them. I want you to try E and F, please.
Does the 2 just go outside of that?
Yep. Because the 4 is going to join the 2 and make an 8. So f prime of x equals, we're going to get the 8 dropping in front, rewrite it. We do the derivative of the outside, then we do the derivative of the inside. What's the derivative of sine 3x?
12 3x times 3.
12 is 3x. And then we do the derivative of the inside, which is 3. So the 3 and the 8 will join, and we will get 24. Cos 3x. And then where does that 3 go? You're going to put it right back in the middle. You're going to sandwich it in.
If you do that, would it be wrong? Or would it just not match?
It just won't match multiple choice.
Okay, but if you swap this, like, sine 3x to the 3 on
Yeah, it just won't match it won't match the textbook and it won't
whatever in
match.
response will be fine.
Yeah.
Like, if you just like doesn't disappear, like, shouldn't we be doing product rule, like, 2 functions?
So if you do product rule, the 2 will disappear on one half of it, but then you'll still be stuck with 8. So you're going to do f times this prime
Yes.
plus this times that. So that whole half's going to go away.
So it's just a shortcut?
So that's why I said whenever you have a coefficient, the coefficient just sits out front and you do the derivative of what's behind it. Because you can do product rule, but it'll just do that.
But you can only do that shortcut for the function.
No, you can do it whenever there's only one function with a coefficient. So 2e to the x. This with a trig function, or like a 3x squared or something like that. But yeah, it really only happens with e's and trigs. Yeah. Okay. Now this one is a product rule. So we have f, we have g. F prime is 2x. G prime is cos e to the 3x. It's going to be quite lovely. And then e to the 3x. And then ln e. I'm just doing the whole thing. And then 3. This happens to go away. So it's going to be 3e to the 3x cos e to the 3x. Okay. So we have to do product rule. So f prime of x equals f times g prime 3e to the 3x cos e to the 3x plus g sine e to the 3x f prime times 2x. And the only thing I can really do is take out an x. Because it's this here and this here. So you can take an x out, and then you're left with 3. And they will do this. They'll bring this 3 to the very front to join the x. So they'll go 3x, e to the 3x, cos e to the 3x. Why can't I take an e to the 3x out this time? Because they're in the brackets with the trig function. You're correct. I don't know why I have one square and one round. Imagine what they're either both square or both round. Then we're going to flip over and practice some trig. Yeah.
When is it where you would be wrong? Because you said like sometimes like you don't think that two things are wrong.
So you're going to be wrong on your multiple choice because it won't match. And next unit, we have to take out GCFs always, or you're not going to be able to actually do the unit. Okay, then we're flipping over. You have to do those questions, obviously. I told you to start working on them if you had time. Okay, now, this one here, this is an example of what we were talking about, David. So if we have this 5 sitting in front of a trig function, you can do product rule. You can go 5 times the trig function, or you can just say, hey, it's going to sit here, I'm just going to get a derivative of that. Because you're right, the 5 is going to turn to a 0, and the other half of the product rule is going to go away. Okay, so I'm going to rewrite this always as cos blah to the 3. You know, blah. So we get 5 cos 3x plus 2 cubed. So what am I going to do first?
5 times 3.
Yeah, the outside. So 5 times 3, that 3 is going to drop in front. And we're going to get 15. Rewrite the inside. Cos 3x plus 2 to the 2. So we've done the outside. We've done the f of the composition, right? The derivative of f. Now we have to do the derivative of g, the inside. So what's the derivative of cos? Negative sine. Anything with a c, the derivative is negative. Negative sine 3x plus 2 times 3 because of the derivative of 3x plus 2. And then they'll always take coefficients. So this 3, this negative 1, and this 15 will all join together and come to the front. So we're going to get y prime equals negative 45. I usually write the sign first, this one's squared. Sine 3x plus 2. And then how would they rewrite this one? The cos 3x plus 2 to the 2. All to the 2.
They would put cos squared.
Yeah, they'll put the 2 in the middle. And that only happens when the whole thing is squared, right? This means the same as this. Done. So for B, we're going to go sine pi over 2, sine pi over 2x, all to the, ow, Moses, 3. Hard Waters, good guy. I don't know why I said Moses. One of my favorite people. Yeah, he parted the waters. Can you do that? I can't part the water.
I thought you said you could barely swim.
Oh, I know I'm a good swimmer. I can barely ski.
No, she was talking to me.
Oh, maybe you can. I don't know. I was a really good swimmer in my day. I didn't drown, so that was good. Still alive, so are you. Thank you. Exactly. Never not. There we go. No, never not means when you double negate, it means it's happening. So stop never nodding. Okay, there we go. Yeah. Never not drown. Never not drown. Oh my goodness. All right. So we're gonna go y prime equals 3 sine pi over 2 x to the 2. The derivative of sine is cos pi over 2x. And then we do the derivative of pi over 2x, which is pi over 2. And so what they'll do is they'll make, if there's any signs in front of the sine or the cos or whatever, they'll put that sign there, but there isn't any. So they'll put the 3 and the pi over 2 together. What's 3 times pi over 2? 3 pi over 2. And they usually put the single one next, cos pi over 2. And then they'll take the 2 and put it right in the middle.
Why do they do it that way if, like, anytime you really, like, have, like,
It's less confusing, because sometimes you'll have pi over 2 squared. So if you had sine squared pi over 2 squared, that makes more sense than sine pi over 2 squared squared. Then people would want to try and put the 2 in with the squared of the pi over 2, which they can't. They're totally just separate.
I don't know, like, I don't understand why they don't, they're like, when you have like a tri or any kind of like polynomial, usually like x squared minus 3x plus 2. But then they're putting them all to the lower degree and trying. Like I just feel like it's kind of backwards to like what you would see.
If you rearrange them, it wouldn't. Right? It's the same thing as a polynomial. If you don't put them in descending order, you're not wrong unless they ask for descending order.
Yeah.
All right. Yeah, sorry.
Wouldn't it be a close pi over 2x?
Yep, it would be. Good call. You can't really see it. It's blending with the bracket, but it's there. Okay. C, we would rewrite the secant as, so we go y equals 5 secant 1 over x all to the 4. Now please, guys, don't rearrange this and put a derivative and say I'm done. People will do that. I'm like, you didn't do a derivative at all. You've just rewritten the question. So please don't stop here. That's just normal. And please don't write derivative. It's not the derivative. So y prime, the 4 is going to drop in front. We're going to get 20 secant 1 over x to the 3. Now I put this one here because the derivatives that we've done so far are always single derivatives. So like sine becomes cos. Cos becomes negative sine. However, secant x becomes secant x tan x, right? Everyone follow me? So everyone does well there. So they go secant 1 over x tan 1 over x. Everyone's fine with that. But then they're like, do I have to do the derivative of both of these brackets? No. what was it originally in the bracket? 1 over x, correct? So I have to do one of them. I don't do two. I'll get people doing two of these and then writing it behind. You don't. You have to do, so you did the derivative of the f, then the derivative of g is literally secant x tan x, and then the derivative of the inside bracket. Like we're deriving just this little thing up here, right? So it's 1. So what is the derivative of 1 over x? Well, let's go off to the side. 1 over x is the same grade 10. We're going back to grade 10 again. It's coming to get us. 1 over x is the same as x to the negative 1. So d over dx of 1 over x, or d over dx of x to the negative 1 is negative 1, x to the negative 2, or we can write it as negative 1 over x squared. Because it can drop down. And then this will join this usually. And we'll get negative 20 over x squared. Now keep in mind, what are these all over? This is over 1, this is over 1. We agree? Keep that in mind because I'm going to give you an extra step after. So we're going to get secant cubed 1 over x. And then secant, you can write it first, I don't really care. Second, it doesn't matter. If you're getting hung up on what order to write them in, that is the wrong place to get hung up on. Okay, so this is over 1 and this is over 1. We agree? So sometimes what they'll do is they'll write the whole thing over x squared. Like they'll just put the x squared on the bottom because I can go this times this times this over this times 1 times 1. So they'll actually write it as negative 20 secant cubed. Nope.
Because you dropped me.
You can. You can. Yeah. Because there's no plus sign in there, and this is multiplied. Sure. Oh, I have to erase the whole thing.
Yeah, because you can't.
When in Rome, secant 4. That's what I say. You know you're only pressuring yourself into erasing this. I pressured myself into erasing it. Because you have one secant 1 over x and you have another secant 1 over x, so that's 4 secant 1 over x's. Because they're all multiplied, like this is a multiplication in here. It's like x squared times an x. You can make it be an x cubed, Lucas.
I see what's going on. I just don't like it.
Well, you don't have to like it, so that's okay. We're going to do that.